Okay. Why? Explain why nitrogen trifluoride is stable and but nitrogen bromide. Okay. Explain why nitrogen trifluoride is stable, but nitrogen trichloride, nitrogen tribromide, and nitrogen triiodide are explosives. Nitrogen trifluoride is very stable gas. It is largely unaffected by water and by most chemical reagents, including acids and alkalis. Among the nitrogen trihalides, nitrogen trifluoride is the only compound with an exothermic standard enthalpy of formation minus 109 kilojoule per mole. The nitrogen-fluorine bond is considerably stronger than the other nitrogen-halogen bonds like chlorine, bromine, iodine, resulting in a high bond dissociation energy and enhanced molecular stability. In addition, the stability of nitrogen trifluoride is attributed to the strong nitrogen-fluorine bonding and the contribution of ionic resonance structure with the molecule. On the other hand, nitrogen trichloride is dangerously explosive, photosensitive, and very reactive liquid. Nitrogen tribromide and nitrogen triiodide are known only as three unstable ammoniates, such as nitrogen tribromide ammoniate, nitrogen triiodide ammoniates. These halides are endothermic. It means nitrogen halogen bonds are weaker, hence these molecules are very low rate of dissociation, which makes them explosive. Okay, nitrogen trifluoride is stable because the nitrogen chlorine bond is very strong. Chlorine is small and highly electronegative atom, which allows effective overlap between the orbitals of nitrogen and fluorine, resulting in a high bond dissociation energy. In addition, nitrogen trifluoride has a negative standard enthalpy of formation, delta HF equal to minus 109 kilojoule per mole, indicating that its formation is energetically favorable. The stable of nitrogen trifluoride is also enhanced by the contribution of ionic resonance structure. In contrast, nitrogen trifluoride, nitrogen tribromide, and nitrogen triiodide contain much weaker nitrogen chlorine, nitrogen bromine, and nitrogen iodine bonds. If the size of the halogen atoms increases from chlorine to iodine, orbital overlap within the nitrogen becomes less effective, leading to weaker bonds and lower bond dissociation energies. These compounds are therefore thermodynamically unstable and readily decompose into nitrogen gas and the corresponding halogens. NX3 nitrogen halogens, chlorine, bromine, iodine. Since the decomposition is highly exothermic and produces very stable nitrogen molecules containing triple bonds. Even slight friction, shock heat of torch can trigger rapid decomposition. Therefore, nitrogen trichloride, nitrogen tribromide, and especially nitrogen triiodide are highly explosive, whereas nitrogen trifluoride is stable.